Hi, welcome back to the breadboard. In this video we're going to continue the series on the CNC router, and what I'm going to show you is some of the wiring I've done. Now, I've been working in the basement because it's often around 0 outside, and so the garage is getting a little cold, and the components like the gantry here and the main controller board just down here I've built in a way that I can actually do a lot of the wiring down in the basement of my house, and then I'm going to move it out and hook it up to the main part of the CNC when it's ready. So I haven't videoed all of the physical wiring because I guess most of you are going to know how to wrap or run a wire from point A to point B and things like that, but I am going to provide some schematic diagrams and things so that you can see how I've wired this up and what I've used for it. Now, there's going to be two parts to this one video. One is going to be looking at the gantry itself and what I've added to the basic mechanical design that was part of the previous videos, and the second part is going to be the controller itself. I think I'll probably divide this into two videos just to keep it easier watching, and what we'll do is we'll look at the first video on the gantry, and then the second video we will do the control circuitry. Now, what I'm going to show you here is how to put the control circuitry together, some tips on wiring and things like that. I'm not going to go into the theory of how the stepper motor works and how the controllers work and all that kind of stuff, but I will be covering those in additional supplementary videos, so don't worry that you're going to miss out. You're not. And the same thing goes for the gantry. I'm going to cover how I put it together, tips to watch out for, things like end stop mechanics and stuff like that. I'm not going to go into the theory about how the steppers work and things again in this video, but more how I put this together, tips and what to watch out for when you're assembling it to try and save yourself some time. And believe me, I learned this the hard way myself. This is the first time I'm doing one of these kind of projects, even though I'm familiar with industrial control and electronics. It's never been applied directly to building a CNC router and stuff like that using the V-slot open builds, aluminum extrusions and things. So we'll go through that and things as well. Anyway, so to that end, I'm going to take the camera off of the tripod because I want to be able to hand hold it. So apologize if it's a little bit shaky in a moment, and slowly go through the actual build of the gantry so that I can show you all the pieces close up and everything else. So we'll be right back. So you'll have to excuse the mess in the lab at the moment, but these things are pretty big, and so they're taking up a lot of room and causing a bit of clutter down here. But anyway, this is the gantry. So it's 1.5 meters wide, and as you can see, it sits about 8 or 10 inches. I don't know, how high is it? The main gantry is about 10 inches tall, thereabouts. Yep, 9 inches, plus the Z-axis itself probably makes it up more like 10, and then when you've got everything else included, we're probably up to about 18 inches to the top of the stepper motor. So if we start at the far end, let's just move down here. So this is the right hand side of the gantry. Ignore this power supply there for a second. And what we have on the end here isn't positioned yet, but we have an end stop sensor here, which is I bolted it onto the back of the 20 by 40 V-rail using some brackets I made. This is one of the things I was mentioning in the previous video. You want to make sure you have plenty of T-nuts, the nuts that go in the slots on the rail for attaching things. And I think right now I've got 1, 2, 3, 4, 5, I don't know, about a dozen T-slot nuts on this back rail because I've got cable tray, brackets, sensors and things like that all mounted to this back one because it's an easy way of doing it. Anyway, let's just start at the end here. We've got the stepper motor mounted to the plate, which I showed you in the last video. And what I've done is I've used some expanding cable sheathing to cover the wires, and I've soldered on some 18 gauge multi-core. That means it's got multiple wires inside each individual wire, and I've picked the same colors as the stepper motor was using for the coating, so that I can run it down and know which ones are which. This isn't coated beyond this point here because it's going to be disappearing into cable trunking. This is over here so it doesn't catch on anything when it's moving and keeps it neat and tidy. But ultimately it's going to be inside this trunking, which is obviously already being fed into, so it's not an issue. The sensor at the end here, it's just basically held in rough position right now while I start off with getting the electronics up and running, is to detect the Y travel, that's to the front and back of the CNC table, when it hits an end stop. And the end stops are going to be screws they're going to be projecting up off of a bracket to detect when the gantry gets to the end of travel. This is a Hall effect sensor, so as soon as it gets physically close to it, it will trip, and it's an NPN sensor. What that means is that it will ground the pin it's connected to rather than supply a voltage into the pin on the controller. There's two kinds you can get. You get what is termed as PNP and NPN. These all work on about nominally 24 volts, although there is quite a wide range from about 10 volts right up to about 32. But within industrial control systems, they're pretty much always using 24 volt supplies. And so you provide this with 24 volts. It only takes a few milliamps of current. This one's as a Hall effect sensor. And when you get a magnetic field near the sensor, it will ground the signal pin through using an NPN transistor in this case. If it was a PNP type, it would actually feed 24 volts out of the sense pin to the controller, and that's depending on what kind of PLC you're using or control system, you would pick the right one to suit that. In my case, I'm using NPN because I'm driving into or was going to drive directly into an Arduino Uno input pins. I'll go into the reasons of why I'm not doing that now in a little bit when we go on to the controller side of things. Anyway, so that's what this is at this end. You've got the rollers and everything else. You've already seen that. The other part at the top here, which you didn't see before, is the GT3 track, the belt, which feeds along the inside of this track here, and is using a T-nut and a screw just to clamp it tightly in place at one end. That runs all the way down the track to the motor down here. And if I'm just going to move around a little bit so you can see. And as you see here, it comes underneath the wheel on the x-axis, up over the motor to the 20-tooth GT3 wheel, back down the other side and underneath the far wheel, and then off to the other end, where it also uses a T-nut screw and a screw to hold it firmly in this place. Now, one of the things I might do as a modification to this is to put another GT3 belt upside down all the way along the track so that it minimizes any stretch, because right now it's not locked at the moment or powered up, but it will, there is a tiny bit of play, and I'll show you that a little bit later. It's not very much, and it may not affect it during normal operation, but having an additional GT3 belt underneath, providing some additional grip, will probably eliminate some of that. Anyway, one of the things I wanted to show you just before I came along, I mentioned before that these Hall effect sensors, I'm using brackets with screws. So what I have here, these are just steel screws where I've put them through a bracket, and I can adjust the height of it so that as the gantry moves across, and in this case, if I just, everything's powered off and disconnected, so I can move these steppers slowly. They will generate an EMF when you move them, so don't ever move them quickly when they're connected to the controller. So I'm just going to move this across, and you can see here I've got this x-axis sensor here, which is another Hall effect one pointing down. It's just mounted to the gantry slider here, the frame that goes over for the x-axis. And as I come across, you can see this screw here, and it will come across, and then as it comes over it, it's very, very close, within a few millimeters, and that will be detected and act as a hard limit switch. It's not really hard because it's not physically hitting something, but it's close enough, and it will tell the controller that it can't go any further. And just by adjusting two screws underneath here, if I just go down a little bit, in here there's two mounting screws that are connected to a T-slots nuts. If I just loosen those, then I can adjust the position of this to suit my desire. So you want it close enough that it's not going to have the mechanical part of the travel hitting the end of the gantry, because that can actually cause physical damage to the mechanics of the whole CNC router, and you really don't want to do that. So you want to stop it with enough gap that even if it overshot slightly through momentum, it's going to stop and not go crashing into the end. So that's why these are adjustable, so that you can just set it up to the right position when you start tuning the system. So that's one end. Now while we're here, we're now onto the X-axis control, which is, we've got the stepper motor here which drives the X-axis, which brings the head left and right on the table. And what I've got is this cable trunking that I've added. These were all the electronics here were provided by RS Components, so I'm very grateful to them for sending it to me. But you can get these from a lot of places. RS Components stock them and will ship them to you, or in North America you can use Allied Electronics. What this does, as you can see here, is as the head moves, it unwraps and it basically lays itself down a bit like a tank track, and it prevents all of the cables that are running through the inside of it from getting kinked and caught or snagged, which can damage them. And also, by keeping a nice curve on the cable, it increases the life expectancy of the cables before you'd have to replace them. Because remember, it's metal inside these cables, even though it's multi-strand copper, and after a while of flexing, it will eventually give up the ghost and break. So what this kind of tracking does is it absolutely minimizes that without being too stiff. This is, as you can see, this is quite flexible. So it just sits here, it just floats basically on top of the 2040 track, and will lay itself out as it needs to, and it'll, you know, this is a 1 meter length, and it easily covers this full 1.5 meter track, because it's basically mounted in the middle and it runs around to the head. So it'll just wrap across to the other side, as you can see here, where it gets to the other limit switch. All right, and you know, while we're on the subject, I've used this sheathing everywhere for covering the ends of the stepper motors and things, just to provide some protection. Once I'm inside the trunking, I've left the cables bare because I want to give them as much freedom to move as they need to. And this is just some wire that I had, which is a few 100-foot rolls of 18 gauge multi-core wire. So it's good for about 5 amps of load from the steppers. Now my steppers only carry about 3 amps, so I'm slightly overrated. But I wanted the option to be able to tune things or change things around later on, so I put 5 amp cables in here, the 18 gauge. It's not exactly 5 amps, but it's close enough. And then the other wires that are coming through here, of course, are the sensors. If you look at this, I've got 2 of the sensors. This one here is for the Z-axis. I don't have the matching screws mounted in here yet. I have to take the top off to put a couple of T-nuts in to put some screws on there. And of course, like I was saying, you need to try and pre-plan this. And I wasn't sure where I was going to put the sensors on initially until I had it built, and then I could just play around with it. So I've got one mounted down here using the standard bracket. This one here with a standard bracket that comes for the, you don't come with the sensors, but you can buy them to go with the sensors. But I need to figure out the travel for this Z-axis before I put my screws in here to set the limits. And coming along, then we've got the cables coming out of the trunk, the flexible trunking, into some permanent trunking. Now this trunking here along the back, I mounted this here because I wanted to be able to take the end plates off of the gantry without having to undo all the wiring. And initially what I had done was I had some cables running right along at the top here, through a piece of flexible pipe to the end, and then coming through this hole here. And the problem with coming through this hole, it's nice and neat and everything else, yes, and I even drilled a hole here thinking I'd bring a wire right through the middle of this from the far end stepper motor, is if I ever wanted to take this gantry off, or this end plate off, and one of my sponsors that I work with is actually talking about sending me some extra height end plates. And if I wanted to put them on here, I would have to undo all the wiring, pull them out, and then put the new plates on and then reconnect it all. So one of the things I decided to do was not take advantage of the holes that were there for wiring to come through, and actually put this cable management trunking on the back of it. And all it took was a few T-nut and screws through inside just to mount it on the back here, and it holds it very, very well and keeps it all nice and neat, as you can see. And then I bring the cables out just behind the gantry and make my connections to the next track. Now this one is sitting here loose because it actually needs to be screwed to the table once I take the gantry back out. So I've got the bracket already here for it down there, but in order to, and I've run the cables through it because with the connectors here, they're too big to go through this once you've got all the wires in. So I pre-ran the cables and then connected the adapters to go up to the steppers and things on the ends. One of the things you notice here, and you might be thinking these connectors are very familiar, and they are. They're actually been recycled from hard drive power connectors over the years with all the PCs and everything I've had and motherboards I've bought. I've slowly collected a whole bunch of these power supply adapters for the old 3.5 inch, 5.25 inch hard drives and floppy drives. And what I did was I just cut the cables off and I resoldered them to the new cables and used some heat shrink tubing to prevent any shorts and things like that, and then just tidied them up. And these make very, very good adapters because they're capable of carrying a reasonable current and voltage. They're easy to get a hold of, and most of you are probably going to have some of these lying around, and even if you don't, they're pretty cheap to pick up from secondhand stores and things like that. Anybody you know that's had some old PCs and bought power supplies, there's always an excess of them. So I made use of these connectors. This is for the Z1. It's not connected yet because I don't have the limit switches on the Z over there, and I don't want it to be driving down into the table and knocking all of this off. So I deliberately kept it disconnected. Everything else is all wired up. Anyway, so what I can do here, what this allows me to do, is completely disconnect the gantry, this whole access here, from the table once I've installed it, without having to worry about unwiring everything. I just have to pull apart the 4 stepper motor controls and the 3 wires for the sensors. And what I've used here are some connectors I had. Now these ones are not reused. I actually bought these connectors a long time ago and they're just parts that I use. But I've used phone and a phone extension cable, which is flexible wire, not the kind you use inside the walls, which is usually solid wire. This actually is a multi-core but lightweight phone cable. It's 4-core, and I'm only using 3 of them. 2 of them are carrying 24 volts, and the other one is carrying the signal. And 24 volts is more than easily handled by these cables because there's only a few milliamps of current, and telephone systems often will have up to 50 or 60 volts DC on them. So 24 volts is not a problem here either. But again, easily disconnected. As you can see, they just come apart with the 2 pins. Now, you might think that with everything moving, they're going to pull apart, but they're not, because this part of the cable system coming out does not move. The only piece that moves is the tank track kind of cable management flexible conduit there, and also this one here. But the piece in between is actually bolted down, and so this is not going to be doing any moving around. Yes, there'll be a little bit of vibration as it moves, but appropriate cable ties and things like that will prevent things from coming apart. So I'm not worried about that. Anyway, so it runs through this cable trunking here, the flexible one, and then it all comes out at the end. Now, when you run this cable through here, you want to try and keep the cables from twisting around on each other so that they don't knot or anything else. And it also means that if you have to pull one cable out, you can do so a lot easier. And also it minimizes the any noise and things like that too, to a certain extent anyway. That then runs down off to my control panel here, which I'm going to describe in the next video, so let's ignore that for the moment. Anyway, back to the end of here. Here's my other screw cable stop. And what else have we got here to have a look at the moment? I think that pretty much covers the gantry. Just looking at the front here a moment, this particular bracket, one of my viewers offered to print a replacement for me because I've designed a new one which is 30 millimeters thick, specifically for my Bosch Colt router, and my 3D printer went on the fritz. It literally went up in smoke, so it's currently being repaired and it should be getting shipped back to me in the next few days, all fixed and hopefully working, so I'll print the proper bracket for this. The CAD files I will put on the site once I publish everything on the RS community site and on my own website, so that you'll be able to download it and print your own if you're using a Colt router. And on the front, I've just used a couple of these same brackets to bolt it on. The design of the one that I've got to be 3D printed is specifically done for mounting on the 6020 rail and for the Bosch Colt. So it's got the holes all set for M5 screws. There's 4 screws on the front that I've put. These two are 2 separate brackets that were from Thingiverse. So I've got some M6 screws in these at the moment, but my one's going to have 4 M5 screws for the front bracket for screwing it in. All of the holes that I've put on my design also have the ability to be threaded, so that you can mount things like vacuum or lighting or various other things onto the router mounting bracket as well, because obviously as you start growing this thing, you're going to want to add vacuum dust collection and stuff to it too. At the top here, again, another temporary measure for mounting the stepper motor. I actually have a 3D print to do, which is going to carry this. What I've got here is the main plate is actually for a NEMA 17 stepper motor, and I have a NEMA 23. The routers are quite heavy, and I wanted to make sure I had plenty of power. And so I just have this from Thingiverse. I just modified it a little bit. Bracket allows me to adapt from a NEMA 17 stepper out to a NEMA 23 stepper. And then you've got your flexible coupler in the middle here that allows you to couple your stepper motor down to your Acme rod, which is what drives the whole assembly up and down on the gantry. So I think that pretty much covers everything on the gantry. I'm sure there's going to be questions. Looking at my diagram here, which I'm also going to publish this 3D model, you can see that basically is what we've just looked at from here right through to the other side. I don't have the electronics shown on the gantry on this 3D model, which is why I'm doing these videos here to just show you that. But anyway, that's pretty much everything that I've done. So the main thing that I think tip-wise is, and I've already covered the basic mechanical assembly of the gantry, is you can never have enough T-nuts. Now I found that the top really doesn't need any additional ones. I've got these 2 sitting here, but I'm probably just going to move it right to the end and put a screw in to stop it rattling around, but I really currently don't have a use for those. On this back 4020 though, with the conduit, which has got 1, 2, 3, 4, 5, 6, 7, about 8 T-nuts in it. Plus, that's on the bottom of the bottom rail. There's 2 slots on the back here, so I've got 8 on here. Plus, I've got my sensor mount at the back, so there's about 10 T-nuts on the bottom rail at least. So I would probably put in 10 or 12 when you're assembling yours on this bottom rail. And then I've also got 4 on the top for adjusting the end stops. So I've got 2 here into the rail and 2 at the other end for that sensor screw into the rail. So that's at least 4. Now I've deliberately not put anything else on the top rail to allow me the ability to move this around a bit without any obstructions. Now of course the conduit gets in the way, but you're really not going to be moving outside of this range anyway. And with everything else that's moving here, you can't really put too much else on this top slot. Again, if you want to be able to disassemble things, don't run your wires through the holes, bring them out the outside edge. When I originally did all this wiring, I did not have it broken here, so I concluded very quickly that that would be very problematic down the road if I ever wanted to disassemble this and do some modifications. I would either be cutting the wires and trying to patch them later on, or I would be trying to pull them all through and everything else. And because of the connectors on the far end of the wires, which we're going to see in the next video, you couldn't pull them through without desoldering them all. So this made a lot more sense where I could just disconnect here. This track can stay on there, and if I modified the stepper motors, put something else in here, I could still use the same wiring potentially, depending on what I put in, of course, without ripping everything else. The sensors, again, these ones only come with 1 meter length of wire on them, so you have to make some kind of connection. So again, I wanted a quick release that was within the voltage rating, but because there's so little current flowing through here, I didn't have to worry about using big ones like this. Now, if you want to buy connectors with screwable, more permanent locking mechanisms, go for it. If you're on a budget like I am, RS Components provided a lot of parts for me, and they asked me what I wanted, but at the time I didn't realize that I'd be wanting to make connections that were in mid-air like this. You'll see the connectors, that the Amphenol ones that they've provided to me for the main controller interfacing, and given the choice, I probably would have asked for a few for here as well, and I may yet do that in the future. But for now, this should work out fine, and if I do have problems with it, then I'll look at updating it. But I don't anticipate any issues here. These things, they have a very good grip, and they do have a small locking mechanism in them with a little slot indents that click into place, so I don't anticipate that I'm going to get any issues. Anyway, I've said it once, I've said it twice, and I'll say it for the last time. That pretty much concludes the gantry as far as how I've wired it all up and everything else. And as I said, I will provide full schematics for everything so that you can build it yourself and better understand it. I know that some of you are concerned that this may be overly complicated system for understanding, but I will endeavor to make it simple. So just to finish off, I'm just going to run down. So this I've shown you the table that this is all going to go on. So obviously this is the 1.5 meter gantry. I do have slight reservations as to whether it's going to be stiff enough for this length. So one of the things I might have to do later is actually shorten the gantry too, which is another reason why having the wires not going through the end here is an opportune thing to keep so that you have more flexibility. But the other part is that, as I said, some of these cables are, you don't get the sensors with great big long cables on, so you have to make joints anyway. Also, the distance from the furthest sensor, which is probably the one that's on the travel here, is over 10 feet because you've got the width of the gantry. So when that's at the far end, you've got a 1.5 meters to here. You've got another 1.5 meters to the when this goes to the end of the table to get to the back of the table. So this is going to be mounted roughly in the middle of the table on one side, and then you've got the distance to get up to the control board as well. So what I've done is I've put about 4 or 5 meters, I can't remember the exact length now, of cable basically that goes from the center here down through all the way through here, all the way down, and then up to the control panel. And the cables are terminated, I'll just show you this bit on this video, with these Amphenol connectors. I've got 4-pin ones for the stepper motors, and you can see here I've marked everything with indelible pen on a piece of heat shrink or various other mechanisms. And I've got 3-pin ones for the sensors. Now, the reason for that is because I don't want to accidentally plug a sensor into a stepper motor outlet, and you only need 3 pins. I could have put all the sensors into one with, say, 5 pins or something, 2 for power and then 3 for the 3 different limit switches, but I wanted to keep them separate again for flexibility. The bracket here that I've mounted it into, I've got a few extra holes because I want to be able to have maybe control for a spindle control, some other sensors, temperature, maybe some fluid control later on as well for coolant or something like that, or turning vacuum on and off. So that's just for a bit of expansion later on. Anyway, so each of the cables come into its own connector, and each of the sensors also for the limit switches come into their own connectors. Now, one of the things, just going back to the gantry, sorry, I keep saying I'm about to finish, but anyway, one of the other important things about the gantry is I put, you could put a limit switch physically on here and on the far end, and if you look at all of the CNC controllers based on Open Systems and Shakapoo and other ones like the X-Carve and stuff like that, they all tell you the same thing. If you have a sensor on each end, whether it be a physical micro switch, a Hall effect sensor, or anything else, the outputs of them are actually parallel together. So logically, it looks like one limit sensor. You would use one as, they would act as both a physical limit stop, so that when your head will never be allowed to go beyond that. And secondly, one of them would also act as a home indicator, where when you hit the home to automatically zero the system, it would move the head and the gantry and everything else to a known position until it hit the limit switch, and then it will back off a little bit so that it's no longer sitting on that. Now, if you had 2 limit switches, that's more you have to buy. But if you put your limit switch on the travel, then you only need one for each axis, which I've got 3 limit switches, and I'm doing the job of 6 effectively. And what I'm using is just the sensing element, which in this case is just a simple screw mounted on the bracket at each end. So you know, I don't need to start paralleling up and buying more sensors or micro switches. It's just simply an additional screw, one on each side, and it makes it far easier for wiring, because I've only got the 3 limit switches now effectively coming out of the system, and it's, you know, it becomes much easier all around. And again, the controller only has the pins for 3 inputs anyway, so no matter what, you're going to be paralleling them. Anyway, that's pretty much it for the gantry coverage. I will be going into details of each individual little thing, and I will be taking some higher resolution pictures for you to look at this. And the next thing you'll be seeing this is when I'm putting it onto the actual CNC itself, and we start tuning it and giving it a run for its money. Now, before the end of the controller video, I will show you this being driven on the bench here. I can drive the X-axis across and the X and the Y and the Z steppers, but within a limited amount of control on the bench here. Obviously, you know, the gantry is not going to move anywhere, but the Z-axis part is I can move already across the gantry here. And part of what I'm going to do in a subsequent video, once I've gone over the overviews of these, is to show you the how you tune up the stepper motors and set the configuration parameters for the Gerbil controller. So anyway, I'm going to go now on to do the video for the actual control system and wiring. So see you in a minute.